GPT-5.6 marks the moment AI agents became cheap enough to multiply, shifting the focus of frontier models from raw intelligence to economic scale. As reasoning gets faster and cheaper, we have to determine which agent workflows are actually economically viable, rather than just theoretically possible. Until now, AI architecture operated as a monopoly. Building an automated system required pushing every single task, from complex logical planning to basic data formatting, through a single, expensive flagship model. That economic bottleneck kept high-volume, multi-step tasks strictly on the whiteboard. The compute cost to process thousands of routine steps could not be justified by the return. Unlocking the next generation of AI requires a division of labor that makes complex systems economically viable. OpenAI is addressing this with a tiered supply chain of intelligence. Sol is the flagship, Terra is the balanced model, and Luna is the fastest, most affordable tier. This chart shows OpenAI's vendor-reported benchmark results on the Artificial Analysis Intelligence Index. According to OpenAI, Sol at maximum reasoning matched Claude Fable 5's score, but completed the tasks in 61% less time, at roughly half the estimated cost. Looking at the specific API list prices per 1 million tokens, Sol costs $5 for input and $30 for output. Terra drops to $2.50 input and $15 output, while Luna costs just $1 in and $6 out. In that same comparison, OpenAI reports that the lower Terra and Luna tiers outperform Fable 5 at roughly 1/16 of its estimated cost. This tiered pricing structure changes the industry from buying monolithic intelligence to purchasing specialized intelligence per dollar. Coordinating these tiers is made possible through Programmatic Tool Calling, which OpenAI built into their Responses API. This diagram shows how the API acts as a conductor. It allows the model to coordinate tools and manage intermediate results using in-memory programs. Through the multi-agent beta, a company can assign the premium Sol model to handle complex planning and hard judgment calls. The system then triggers concurrent subagents, utilizing the low-cost Luna tier to execute high-volume, routine subtasks simultaneously. Finally, the API synthesizes all of that concurrent, multi-tiered work back into a single cohesive request for the user. True multi-agent workflows are viable now because systems can surgically allocate premium intelligence for difficult decisions and cheap intelligence for repetitive labor. However, theoretical benchmark economics do not automatically translate into real-world production economics. OpenAI's specific claims, 61% faster speeds or halved costs, apply only to the cited benchmark comparisons. They will not apply to every enterprise workflow. This visual highlights hidden frictions in a multi-agent architecture. Running a live system means managing continuous tool calls, system retries, network latency, and integration delays. Then there are the final critical costs, engineering for failure states and implementing mandatory human review gates required for safety. By the time an agent system successfully completes a task, the total cost of operations moves well past the idealized API token price. Success in the next agent race belongs to the system that spends its intelligence with the most discipline.